Okay friends, here's the results we just got from our little experiment on Excel, which essentially is the same experiment we were doing out here with our penny, except it was much easier because we were able to randomize it much more quickly. The question now, of course, is how do we do an average when you've got data that looks like this? But let's remember what we're looking at. Number of flips 2, how many? 494. So don't forget what that means. That means Excel saw the number 2 494 times. So this is your data. Your data points are either 2s or 3s. This is how many of each of those data points there are. So we could still do this the way we were doing it earlier. We could simply write out 2 plus 2 plus 2 plus 2. I'm going to stop myself if that's okay. Plus dot 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 plus 2 a bunch of times plus 3 plus 3 plus, I'm going to stop myself again if that's okay. Plus 3 a bunch of times. And to be precise, just so you know, there are 494 of these, and there are 506 of these. And then once we had added all that up, we would divide by 1,000. That's what we did last time. We added up all the 2s and 3s, and then divided it by how many we had. Now, last time we had the advantage, of course, of having, I think it was a maximum of 5 trials. So it gets a little bit trickier when you've got 1,000. But the math is the same. You have to add up 2 494 times. So 2 plus 2 plus 2 plus 2 plus 2. Then you have to add up 3 506 times. 3 plus 3 plus 3. But hopefully the word times gives you a hint as to a more efficient way of doing this. Yes, this is correct. It's also going to take you all day to do. This is why we invented multiplication. Because 2 494 times is the same as 494 times 2. So I vote that we rewrite this whole thing, with your permission, as 2 times 494 plus 3 times 506 divided by 1,000. Now I'd like to color code the data a little bit to make sure you know exactly what you're looking at, okay? So the data I'm going to color code, actually I think I'm going to color code it blue because I think that's the colors that I used on the last video. So this 2 and this 3 are the data. Those are numbers of flips. Those are numbers of flips. Okay? The 494 and 506, I'm going to color code those. I think I used red in the last video, actually. So this 494 and that 506 together add to make 1,000. Those are the trials. So even though they're all just numbers multiplied and then added, they actually mean something. They imply either the data or the number of times you see that data. So we saw 494 2s and we saw 506 3s. If we add that numerator together, that's going to tell us how many total flips we got. Then, if we divide that by 1,000, that's going to average it over the 1,000 trials. Let's do that now. So now that you've got it, we now know that on average, it took us 2.506, or just about 2.5 flips per trial. 2.5 flips per trial. What you just did was a weighted average. A weighted average. Whenever your data is given to you in this kind of form, where you've got your data and then you've got a frequency of how often that data shows up, you can do this kind of average right now. It's equivalent to adding up all the raw data and dividing by how many there are, but it's much more efficient because it saves you from having to do all those additions, 2 plus 2 plus 2 plus 2. So you see, what you've got here is a really, really cool way of averaging. Your traditional way of averaging is always going to be valid. This is the same, it's just a more efficient way of doing it. Let's go in and make sure we understand the differences between a raw data average and a weighted average.